All right, so starting off, factor out. So we factor an x out of the denominator. Then we can factor this trinomial into two binomials, x minus 4 times x minus 4. But we write that as x minus 4 squared. So when we set up our equation, we have a over x. And with this x minus 4 squared, we have to have an x minus 4 and an x minus 4 squared. Two separate ones, just the way it has to work. All right, so we have a b over x minus 4 and a c over x minus 4 squared. If there's a squared, we have to do just a regular one to the first. If it was cubed, not that I'll give you any like that, but we'd have like x minus 4 squared, and x minus 4 cubed. And once we get all that, we're going to multiply both sides by the x times x minus 4 squared. Let's cancel everything out over here. Over here, we're distributing each one. This first one, the x's cancel out. We have a times x minus 4 squared, but remember, x minus 4 squared is the same as this. Right, so you don't have to really multiply it out yourself. You should already know it from earlier. So I'm going to distribute the a to all of that for this next step. And then bx, we're going to distribute that. Then we're looking for like terms. So we have some x squared terms. We have some x terms. And we have one lonely constant. So we factor the x squared out, we get a plus b. That has to add up to give us 3. That's our first equation. Factor the x out, we get negative 8a minus 4b plus c. Those have to add up to negative 21. That gives us our second equation. And then our constant gives us our third equation. And that's the nice easy one that we can solve. Then we can plug it back in over here to find b. And then we can plug both of those into the middle equation to find out what c is. After we've done all that, now we have to do the integral part, right? We're taking the antiderivative of this whole thing, but we've now broken it up into 3 separate rational expressions, which means we can separate it into 3 different integrals. So we're going to do antiderivative of 2 over x dx plus the antiderivative of 1 over x minus 4 dx minus the antiderivative of 1 over x minus 4 squared dx. All right, just taking a, b, and c, substituting them in here, and now we're doing the integral, the antiderivative of each of those. Well, this first one, we can go ahead and bring that 2 out in front. And antiderivative of 1 over x dx, we can figure that out. This next one, since it's not just an x on the bottom, we have to use u substitution, or we should use u substitution. X minus 4 is our denominator, that's going to be our u. Du is just going to be 1 dx. So really we end up getting antiderivative of 1 over u du. And then the last one, we can use u substitution again and actually have the same u. But this time we end up with 1 over u squared du. Well, what's the antiderivative of 1 over x? Natural log of absolute value of x. So we get 2 natural log absolute value of x for our first part. Next one, antiderivative of 1 over u is just natural log of absolute value of u. So we get natural log of absolute value of x minus 4. This one, it's 1 over u squared. So same thing does not occur here when this is squared. Right, that's only if it's 1 over u, 1 over x. When it's squared, we treat it differently, like we did the first time we did antiderivatives. 1 over u squared, that's the same as u to the negative second. So we can add 1 to the exponent, divided by the new exponent, or multiply by the reciprocal. Can't do that with these because that comes out to be undefined. But for this one, u to the negative second, we add 1, we get u to the negative first. Multiply by the reciprocal, that negative out here times this negative is going to make this plus. And of course we don't want our final answer to have u in it, so we're just going to replace the u with x minus 4. And we can write it instead of x minus 4 to the negative 1, you can write it that way, or you can write it as 1 over x minus 4 plus c.